there, Teacher Miza here. Welcome to Chemistry with Teacher Miza. And today I would like to cover on topic 15, hydrocarbons. So this topic is one of the under organic chemistry. And let's go. So alkanes are saturated hydrocarbons with a general formula of CnH2n plus 2. And alkanes are hydrocarbons mainly consist of hydrogen and carbon only. So they are called saturated, which means each carbon bonded 4 times with the maximum number of hydrogen atoms possible. Like for example, methane, that carbon will be bonded to 4 hydrogen atoms. And ethane, they will bond. Each carbon will bonded to 3 hydrogen atoms, and with the other bond is with their neighboring carbon. And we also have cycloalkanes, but they are slightly different. The general formula is CnH2n because they are forming a cyclostructure. Okay, so for cycloalkane, for example, here is C6H12, which is for cyclohexane, and the example used here is cyclopentane, which is C5H10. And cycloalkanes are still saturated, and they are a functional group isomer of alkenes. Okay, now let's look at fractional distillation. Alkanes are found in crude oil, which is a mixture of different lengths of hydrocarbons. So this is fractional distillation used to separate these hydrocarbons. Okay, crude oil is vaporized using a furnace to about 350 degrees Celsius, and the vaporized oil enters the column and rises through the trays, and the longest hydrocarbon don't vaporize and run down to the bottom. And you can look here in the furnace over here, the crude oil is injected in the column and rises through the trays here. Okay, and the column has different temperature gradient. It is cooler at the top. Okay, and as the vapor rises, parts of the mixture condense at a different temperature. This is because there are different chain length and hence different boiling points. So the fractions are drawn off at different levels. So here, the shortest hydrocarbon here won't even condense at 20 degrees Celsius and so come off as a gas at the top of the column. Okay, so this is how the crude oil is being distillate. Okay, now let's go into the uses. The fraction can be used in various ways here. Let's look at the uses for gas, which is used in LPG and stove gas, petrol in cars, kerosene for jet fuel and heating, diesel oil used as diesel fuel, fuel oil used in ships and power stations, and bitumen used in roofing and tarmac. Okay, now we look after fractional distillation, we look into cracking. Okay, what is cracking? Okay, so heavy fractions, okay, can be cracked to higher demand lighter fractions. Okay, so fractional distillation will produce a variety of fractions. However, demand for each fraction varies. So heavier fractions like fuel oil are in a low demand. So for a lighter fraction such as petrol, it is more in demand because they are more valuable. Okay, so we can take the heavier fractions and crack them. So cracking is breaking longer chain akin to shorter hydrocarbon. So for example, here is dodecane to form ethene and decane. And there are 2 types of cracking. We have thermal cracking, and second we have catalytic cracking. So what is thermal cracking? This process involves high temperature and pressure used, where the temperature is at 1000 degrees Celsius and the pressure is 70 atmospheric pressure. So product of thermal cracking are mainly alkenes. So it can be used to make polymers such as plastic. So propane is used to make polypropylene. And second, we have catalytic cracking. So it's still high temperature and slight pressure use. Okay, so the temperature here is only 450 degrees Celsius, and they use zeolite catalyst, which helps to lower down the temperature needed, and hence why it is called catalytic cracking. It uses catalyst. So the product of catalytic cracking are mainly aromatic hydrocarbon, which is useful in fuels for vehicles. So aromatic compound contain benzene rings, which is 7 carbon ring with a delocalized electron system. So about this benzene structure, we will discuss further during our A2 later. And by using a zeolite catalyst, it lowers down the temperature and pressure needed for cracking to occur. So this will lower the cost and speed up the reaction.